The next feature I will be talking about is the PDFA support in the GDPicture PDF toolkit. Just briefly to talk about what exactly is PDFA. The PDF document format is very versatile and allows the creator of the document to utilize many different features to construct the document. Some of these techniques proved rather problematic when the need for document archiving emerged because of, for example, documents that didn't have embedded fonts were showing different. The best scenario is showing different graphics but retain their information. So there was a different font, but the information was retained. But in extreme cases, the missing font can completely cause the loss of information on the document. There can be problems with non-calibrated color spaces, and you can lose information in some blending phases of the document as well, especially when printing the document. So these problems basically sparked a movement that formed the PDFA as ISO standard that specifies how the PDF document needs to be constructed and which features should be utilized in order to ensure the documents are suitable for long-term archiving, which is more and more frequently utilized across the world by government, industry, academic and financial institutions, etc. But there was another problem, and basically some documents may claim that they are PDFA compliant, but in reality there can be hidden errors. Basically, the document does not can in some cases the document can be trying to be conformant to PDFA, but errors in the process can basically completely make the document unusable. So basically, every document needs to be validated, and the institutions basically that are archiving the documents needed a way to validate these documents before accepting them. So after several closed source and proprietary validation solutions, so the Open Preservation Foundation, PDF Association, and Digital Preservation Coalition created the VeraPDF project, which had a goal to basically build a precise open source PDFA validator that would act as a default go-to tool that any institution can use to validate PDFA documents. VeraPDF project is great on its own and works very well, but for our purposes, there were integration problems. It is based on Java, and as well the performance issues we could not overlook because it basically was slow for server processing, stuff like that we needed. So we decided to build our own PDFA validation and conversion engines. With respect to the VeraPDF project, we decided to make it our benchmark when it comes to precision and improve significantly on the performance utilizing our own processing technology, which we already had. So our efforts basically resulted in super quick PDFA validation and conversion engines with minimal memory footprints while keeping up with the VeraPDF in terms of validation precision on real-world documents. I will quickly demonstrate the conversion and validation features on the demos that I have prepared here now. So again, I'm opening the same application. The second button basically is utilizing this part of code, which is this one, which is basically just iterating through my input directory and basically converts every file in that directory into the PDFA. So I will quickly run that. We can open the output here, and we should see the files popping in already. So the processing has started and should be finished. It's around 30 documents. Didn't want it to spend much time on it. And okay, I think we should be done now. So to check the documents, basically, if we look at the inputs, we can quickly open VeraPDF and choose, let's say, the conversion and input documents. And let's take the first one, and Vera PDF will quickly show us that the PDF is not valid PDFA. Now, if we open our document, the Acrobat, first off, will tell us that the document is refer to wait is valid, verification succeeded. We have PDFA2B document, and we can also open it up on Vera PDF and execute. And we can see that the profile is valid. We can open the report, and as we can see, the file is passing the validation now. So the file was successfully converted, and I would be able to go through all of these files. You can believe me, all of them would be valid by Vera PDF standards, because, as I said, we have used it as a benchmark for these. The one note is that we have basically processed about 39 files in few seconds on one thread. We can run this on many threads, and the processing can be super quick for server use as well as for desktop use in Office. So very good tool. We can also go to the validation demo quickly. This is this one. So basically, I have again prepared something here, which is these are some random PDFA documents. They claim to be PDFA valid. So we will go through them. We will run the validation demo, and we will quickly show the result of our validator. The first document we are checking is by the our report is valid PDF, where we have 0 failed checks. We can again go and confirm that on Vera PDF if we want. Execute, and as you can see, the validation of single file is taking quite a long time on Vera PDF. Notice that we had this validation ready in split second on our engine. Vera PDF is still running it. I'm sure it will be very soon ready. Sorry for the wait. And we can see that file is compliant. So that is the same conclusion as with our validator. We can quickly check another file. Notice how long it will take. Boom, we have another file validated, and this document failed the PDFA validation. We can check the file, which is 008 something. We will choose the PDF. Validation input. This one, open, and let's validate it. This one was quite quick. Vera PDF, good job. And we can check the report, and we can see that Vera PDF is reporting as well that the files failed. It has some problems in the XMP metadata, which is basically, again, correlating with our findings that we have invalid XMP metadata on the file. And again, I would be able to go through the files on the but there's no point in doing that.